Welcome to chapter 17 textbook, chapter 17 on textbook. It'll be chapter 6 on my lecture. So it's on planar kinetics of rigid body, force and acceleration. So the first part, we'll be looking at mass moment of inertia. So at the end of the lecture, students will be able to determine the mass moment inertia of rigid body of a system and rigid body. So a large flywheel in the picture is connected to the large metal cutter. So the flywheel mass was used to help provide the uniform motion of the cutting blade. So what property of the flywheel is most important for this issue? So how can we determine the value of this property? So it's actually mass inertia, because we need to know where is the axis of rotation. So at the end of this lecture, you'll be able to answer this question. So the crank on the oil pump rig undergoes rotation about the fixed axis, and it's not the mass center. So the crank develops a kinetic energy directly related to its mass moment inertia. As a crank rotates, its kinetic energy is converted to potential energy and vice versa, because this goes up and down, right? So is the mass moment inertia of the crank is about the axis of rotation smaller or larger? So that's the thing. Okay, so mass moment inertia, it's given as T equals to I alpha. Let me just try to make this simple. In linear movement, we have F equals to ma, right? Linear movement, we have F equals to ma. What is m? It's the mass. What is a? A is the acceleration, linear acceleration. But in rotation, for rotation, we can't use this equation, right? It's not valid because it's for linear. So similar to this, not the same, but similar to this, we have T equals to I alpha. So what's alpha? Alpha is the rotational acceleration. And why? What is the I? I is the mass moment of inertia. Okay, so you get the relationship now. This is for linear, this is for rotational. So the first part of the chapter, we'll be looking at how to find the I, because it's something new to you, right? Probably you have studied this in physics. The first part of the chapter will be showing you integration, and also how to find the value. I will straight go to the usage of the this is the procedure for analysis. Usage of the formula itself, because in our syllabus we don't test, we don't find for the value. The value will be given to you, but you need to also find using the formula, the given formula. So this is called the parallel axis. Parallel axis, where it is I equals to Ig plus md square. Okay, so the value of moment of inertia I equals to Ig plus md square. So what does it mean? In total, there are three formulas that you need, three methods in how to find the I value. Three methods. Let me just discuss all the three. Okay, one of it is actually from the textbook. So where is from the textbook? You turn right to the last page of the textbook, you will find this. Okay, can you see? Standard. It's all given to you. Okay, but let's analyze one of it. Let's take these, enlarge these, and analyze one of it. Okay, look at the axis. Oops. Okay, axis XX. Axis XX. So what does it mean by axis XX? It means this thing is running at this axis. So when it's running at this axis, this cylinder is going to rotate around that axis. Very difficult for me to show you. What about axis YY? Axis YY is somewhere around here. So what does it mean? It means this cylinder will rotate about axis YY. That is the moment of inertia. If axis ZZ, it means this cylinder will just rotate. You just hold a pen and just try to rotate in your hand. So you can imagine, if ZZ, this is the middle axis, and this cylinder is going to rotate this way. So that is the interpretation of this. So if you read the question, you look at the question, if they give you a cylinder, which is actually the axis is right cutting in the middle, then you use this ready-made. These are all ready-made ones. Okay, and if let's say that in the same cylinder question, the axis is running in the middle here at x, or y, y, then you just imagine this thing is turning around, flipping, turning around. Yeah, so you have to use this equation. Okay, so this table is available behind your textbook. Yeah, it's all ready made. Can you see the values? I, x, x. Yeah, and then you see this. Where is the I? Where is this? That's the reason why I don't require you to actually calculate and go through the integration and all this complicated thing, because it will be provided to you. So just use as it is. Yeah. Okay. Now going back to the lecture. The second one, okay, the first one is from the textbook, just available from the textbook. Okay. Now sometimes, yeah, question will not have the standard one. Okay. Let's say just now we were talking about a cylinder, right? Okay, a cylinder. So cylinder axis is here, right in the middle. We say ZZ axis. So ready-made says middle here. But sometimes the question can shift. They say the cylinder is actually rotating about this axis. So what does it mean? There is a distance between this axis and this axis, right? So that is D value. So just imagine the cylinder now is going to rotate. Yeah, rotate about dx, this axis. So it's no more rotating on this, but rotating from this axis. So it goes around. Yeah, it goes around. So if you see the top view of the cylinder, okay, this line is this. Yeah, this line is this top view. So the cylinder would be like rotating, you know, cylinder would be rotating here like this, like this, like this, like this. Yeah, moving from one point to one point, maintaining the distance of d. This is the top view. This is the top view. This is the side view. Okay. If you don't understand, then we can meet up in the in the consultation hours, and I re-explain to you. Okay. Just remind me to explain to you. So now from the textbook, you have a standard package. Yeah, standard package which have actually given you everything. So that's method 1. Method 2 is when you do not have a standard one, where you have a standard one, but the axis has been shifted to a distance d. So what you have to do, you take the md square. Okay. Now the third one will be ready-made. Wait, let me see. The third one is a jackpot question. Where is the slide? Yeah. The third one is radius of gyration. If radius of gyration is given, the k value is given. K is the radius of gyration. Yeah, is given. You don't have to look at the textbook or anything. You don't have to turn anywhere. You just take the value, the k value, you square it, and then you multiply with the mass. So you get the moment of inertia. Just like that. Yeah. Okay, so these are the examples, derivative examples. Okay, let's look at these. This is simple. You can just go through it. I'll go through a bit more complicated example. Group problem solving. Okay, let's look at example 17.3. Yeah, from the textbook. Okay, let's look at this. If a plate shown, has a density of 8,000, so density is actually 8,000 kilogram per meter cube. Okay, 8,000. Okay, and thickness of m 10 millimeter, and the moment of inertia axis perpendicular passing through O. Okay, so if you look at this is the object that you need to look at. Okay, so what happens? The axis is actually shear. No, it's not in the middle. So look carefully at it. The axis is here. It means from top view, the coin is going to travel, or the plate is going to travel like this. Top view is rotating this way. You understand it not? Because the axis is O. O is right in the middle. Yeah. Okay, because the O is here. So this thing is going to rotate around like this. Move. So the thing will be going around the point O, going around. So this is the middle. Okay, that's how the movement. Okay, now what you have to do is that there is a hole in the middle. Okay. So we redraw. So we have the plate, and then we have the hole. The hole, you see, you have to minus. You have to minus the hole. Okay, let's look at that. So if it's at the side here, so let's see whether we have a ready-made one or not. Yeah, so we go back to this formula. We see the side plate. Do we have a plate? Yes, we have a plate. This is nice. So we have a plate. We have ZZ axis, which is at the side here, correct? So ZZ is 3/2. The middle will be 1/2. So it depends. If you want to take the middle and then add MD square also can, yeah? You add MD square also can. Or you want to take at the side also can. So let's go and see what did they do, okay? Okay, so for first part is to find the mass. So what's the mass? You take the density, you multiply with the plate. So the plate is pi r square thickness. Yeah, it's like a, what do you call, like a cylinder, right? Yeah, you take the area, cross-sectional area, you multiply with the thickness. It's like a cylinder's formula. Okay, so we have pi r square 0.1. Okay, so this part is done. So you get the mass. So the mass for the big plate, this is the disc, not the hole, the disc. Okay, so now where is the what do you call, where is the, at the side here, right? Isn't it the side here? Okay, the axis at the side there. So what they have taken is, let's look at this. They have taken the middle. But if you want to take 3/2 also, no problem, but they have taken the middle. Okay, if you take the middle, it's half mr square plus with the md square. Okay, what is the distance? The distance is the radius. Okay, the distance is 0.25. Okay, half half mr square plus with md square. Okay, this is md square. Okay, now if you want to take in the middle, at the side there, then you just have to take 3/2 mr square. Finish story. It's actually the same value. Yeah, because this is 1 md square, this is half mr square, the radius is the same. If you combine, it is actually 3/2. Okay, it's your choice, but you have to be very careful, because whatever that you choose have to be correct, right? Just to be in the safe side, you take the standard one and then you plus with the mb square, so you get 1.473. so the disk is 1.473. Now let's calculate for the hole. Once again, take the mass, multiply with the volume, the volume of the hole itself. The radius is much smaller. Can you see that? 0.01. Then you get your 3.927. Okay, that's done. Once again, it is half mass, half mass r. What is the radius? Okay, let's look at the radius. The radius is actually 1.25. Okay, fine. 0.25 m d square. Now let's look at that. Why the d they took 0.25? Yeah, because the hole is here, but the axis is here. So this and here is actually 0.25. So that's the reason why they actually add with md square. Okay, which is 0.25. Okay, so with that you get your mass of the hole, which is 0.276. So the moment of inertia will be the disk minus with the hole. So this is the value. Okay, now if you are confused or if it's not clear, you just let me know. Yeah, I can re-explain to you. Yeah, so with this we have finished the first part of chapter 17. Yeah, I will see you in the next video. Thank you.